Hello everyone, my name is Hossein Mehdipur. I'm PhD candidate at Missouri University of Science and Technology. Today I'm going to talk about my work, which is about the joint bidding strategy of physical market participant with virtual bidding capability in FTR auction and day-ahead markets. First, let me talk a little bit about the motivation of this work. In a power system, we have a transmission line, and whenever we have a transmission congestion, we have a price separation at different buses of the system. It means that the prices of different buses are different. We call it locational marginal pricing. In these cases, the payment to the generation company is not equal to the revenue collected from load. And the difference between these two values is called congestion charge or congestion revenue, which is collected by independent system operator. But ISO is non-beneficiary organization and wants to redistribute this money to the market participant through another auction, which is called financial transmission right auction or FTR auction. And FTR is a product that has some features. It's defined on a path. It has one sink bus and source bus, and the FTR value is calculated based on the day-ahead LMP of these two buses. So the FTR value is the day-ahead LMP difference at sink bus minus the day-ahead LMP at source bus. So these two markets are interrelated. So the market participant may intend to develop a joint bidding strategy in FTR and day-ahead market to maximize its profit. On the other side, we have a virtual bidding. Virtual bidding, when market participant using the virtual bidding, it can participate in electricity market without any assets. In this way, I'm going to show that using the virtual biddings, the market participant can manipulate the FTR value so it can maximize its profit. And this is the appropriate tool for the market participant to use and maximize its profit. So the contribution of this work is that we want to show that the possibility of FTR manipulation using the virtual bids in a day-ahead market, and we propose the jointly bidding strategy in FTR and day-ahead markets. And we designed 4 cases to show the effectiveness of this model. To show the FTR value manipulation using virtual bids, we assume we have a 5-bus system. In this system, we have 5 generators and 4 loads. And we assume market participant has virtual bids at bus B and wants to buy FTR from bus E to bus B. If we don't consider FTR, the virtual bid profit would be like the curves that we showed in the right side. And when the virtual demand increases at bus B, the price at this bus increases, but the virtual bid value, which is calculated based on a LMP price minus the head price, decreases, which is shown by the blue curve in this figure. And if we calculate the profit of virtual bids, we can see that the profit of virtual bids maximize at this point, which corresponds to the 10 megawatt of virtual demands. But if we consider the FTR as well, as you can see, it is true that the virtual bid profit decreases, but the FTR value, which I said that this is the difference between the day ahead between the sink and source process, the FTR value increases. And if we calculate the total profit, we can see that the total profit get maximized at this point, which corresponds to the 40 megawatt at virtual demands, which is completely different than before considering the FTRs. So it shows that when we considering the FTR auction and bidding strategy in these two auctions, the strategy of market participant changes. So we proposed the 2-stage, 2-level bidding strategy problem. In the first stage is related to the bidding strategy in the FTR auctions. In a second stage, it is related to the bidding strategy in a day-ahead market. And as I said, the FTR value is based on a day-ahead market prices. So these two markets are interrelated to each other. And to present the effectiveness of the proposed model, 4 different cases are designed. In the first 3 cases, we assume that the market participant can participate separately in FTR auction and day-ahead market. And the 4th case, using the proposed model to design its bidding strategy. And the difference between the first 3 cases is that in the first case, the market participant uh, has access to the accurate prediction of the LMP difference. For the case study, we use the 5-bus system. The left figure shows the FTRs, offers and bids in a FTR auction, and the right side figure shows the offers and bids of generator and load in a day-ahead market, and this table and curve shows the results. As you can see in case 2 and case 3, the FTR profit is negative. This is because we have an inaccurate prediction of the LMP difference in these two cases. So the FTR profit is negative at this point, which causes the smaller total profit for these two cases. So we're going to compare case 1 and case 4. And in these two cases, if we compare these two cases, we can see that the market participant behavior in FTR auction is the same, but this market participant wants to change the FTR value using the virtual bids. And as you can see, the um, sink and source LMP are changing in case 4. So the market participant can make more profit from the FTR in case 4, and as a result, the total profit of this market participant can maximize at case 4. To conclude our work, we can say that the strategic generation company faces complicated decisions due to the conflicting options that it has. For example, it has a trade-off between the profit in a day-ahead market and the profit in FTR auctions, or uh, the trade-off between the FTR quantity and the subtract of the LMP and the FTR auction prices. And as we showed, the strategic generation company can make higher profit by employing the virtual bids. Actually, using these virtual bids, this market participant can manipulate the FTR value and increase this profit in it. And the interesting point is that the market participant may intentionally lose money in a day-ahead market, but it wants to increase the value of FTRs and maximize its profit by increasing the FTR value. Yeah, yeah, that's it. And thank you for your attention.